You know that moment when you punch something into your calculator, maybe the square root of a negative number, and it just yells error at you? It feels like you've hit a wall, right? Well, today we're going to see how that exact error message actually blew a door wide open to a whole new dimension of numbers. So here's our game plan. We'll start with a quick refresher on square roots. Then we'll run right into that negative number problem. After that, we'll see how mathematicians got creative and literally imagined a solution. Then we'll mix that solution with the numbers we already know. And finally, we'll see why any of this really matters.
All right, before we get into the really weird stuff, we gotta make sure we're all on the same page with the basics. So let's start with something you've probably done before, simplifying a square root. And hey, no calculators for this part.
It's really just a simple five-step process. I like to think of it kind of like a matchmaking game for numbers. You break down the number inside that square root symbol, you look for pairs of identical factors, and you let each pair escape the house as a single number. Any number left without a partner? Well, it's got to stay inside.
So, for example, if we take the square root of 75, we can break that down into 5 times 5 times 3. See? We've got a pair of fives, so we pull one 5 to the outside, but that poor little 3 is all alone, so it stays inside. And there you have it. 5 times the square root of 3. Simple as that.
Okay, so that process is pretty straightforward, right? But what happens when we try to do that with a negative number? This is where our nice, neat little math world starts to get a bit strange. In fact, if you have a calculator nearby, go ahead and try it with me. Just type in the square root of -4. What pops up on that screen?
Yeah, you're probably looking at some kind of error message. And listen, it's not because your calculator's broken. It's because in the world of numbers we're all used to, you've just asked it to do something that's totally impossible. And here's why.
Just think about it for a second. To get a square root, you need a number that, when multiplied by itself, gives you the number inside the radical. So if you square a positive number like 2, you get a +4. But if you square a negative number, like -2, a negative times a negative is also a +4. You see the problem? There's just no real number you can multiply by itself to get a negative answer. And you gotta understand, this wasn't just some annoying calculator error for students. This was a fundamental roadblock in mathematics. So to get past it, mathematicians did something, well, something pretty amazing. They decided to imagine a new number into existence. And this is the truly genius part. Instead of accepting this as a hard limit, they just decided the rules needed to be expanded. They created a whole new category of numbers, specifically designed to solve this one little problem. So, meet the star of our show, the imaginary unit. We just call it by the lowercase letter I. Mathematicians defined I as the solution to this impossible problem. They basically just said, okay, from now on, the letter I is the answer to the square root of -1. And that's it. And just like that, with one simple definition, our calculator error just disappears. We can look at the square root of -4 and break it into two pieces, the square root of 4 and the square root of -1. Well, we know the square root of 4 is 2, and we just defined the square root of -1 as I. Put them together and you get 2i. Problem solved. This one simple rule changes the entire game. Now, anytime you see a radical with a negative inside, like the square root of -9, it becomes an imaginary number. In this case, 3i. But if a radical doesn't have that negative, like the square root of 200, it just stays a good old-fashioned real number. Okay, so now we have our familiar real numbers, and we have these brand new imaginary numbers. So the next logical question is, what happens when we put them together? What happens when these two worlds collide? Well, that's when you get something called a complex number. And it's actually pretty straightforward. It's got two components, a real part, which we call A, and an imaginary part, which we call BI. This simple form, A plus BI, lets us express a number that exists in both the real and imaginary dimensions at the same time. Let's take a quick look at an example. For the complex number 2 plus 3i, it's super easy to break down. The 2 all by itself, that's our real part. The 3i with the I attached, well, that's our imaginary part. That's really all there is to it. Okay, so let's wrap this all up. Why did we go on this whole journey from a calculator error all the way to a new number system? What's the big takeaway here? And this is why it all matters. The number I isn't just some clever math trick. It is a fundamental, absolutely essential tool. Without imaginary numbers, We couldn't properly describe things like electrical circuits or radio waves or even the incredibly bizarre world of quantum mechanics. They literally make the impossible possible.
It really makes you think, doesn't it? That error message on your calculator wasn't an endpoint, it was a doorway. It makes you wonder, what other incredible breakthroughs are just waiting out there, hidden inside the problems we haven't quite figured out how to solve yet?